Welcome back to another fun geometry video in our Unit 2 Geometry Notebook. We're going to talk about distance today. So that's on page 12, 13, and 14 of our digital notebook. There's kind of a lot to go through here, but not all of it is difficult. So I'm going to zoom in, see if we can see this a little bit more clearly. We've got distance. So we've got a vertical distance on the coordinate plane and a horizontal distance. And if you've got straight lines, you can just count. Make sure you're counting the jumps, not the endpoints. So you're going to start at one endpoint and count the jumps. 1, 2, 3, 4, 5, 6, 7, 8. This vertical line is 8 units long. Same thing with a horizontal. You're going to start at one of those two endpoints. It doesn't really matter which one you start with. I usually start on the left and move to the right because we're traveling along that kind of line on the coordinate plane. We can just count 1, 2, 3, 4, 5, 6. Again, we're counting jumps. So it's 6 jumps or 6 units long. It's 6 little tiny pieces if I cut that into little squares, right? So the problem comes when we have a diagonal. When you have a diagonal, you're not going on these lines that are marked on the coordinate plane. You're kind of going off-road. And when you go on the diagonal, each square is a little bit longer. So you can't just count jumps because you've got little ones and big ones and they're not all the same. So here you've got a horizontal distance and you've got a vertical distance. If you drop a line straight down from one endpoint and you make a line straight across from the other endpoint and you only travel on the grid lines, it's like you're playing the floor is lava and you can't touch any of those white spaces. You have to stay on the grid lines. Then you can use Pythagorean theorem. So Pythagorean theorem, remember the two legs of the triangle, the horizontal distance and the vertical distance, those are your A and your B. And then that long diagonal has to be on one side of the equation all by itself. We've got to square them. Hopefully you remember Pythagorean theorem from middle school. Or we can use the distance formula. So on page 13, we're going to do Pythagorean theorem. And then on page 14, we're going to do the distance formula. The Pythagorean theorem is on your formula sheet, but the distance formula is not. So you're going to have to memorize this one. And kind of the way I remember this is either Frankenstein or like you're thinking about your face when you're in math class. Distance equals, and I want you to write this physically in your notebook at least 3 times. You're going to draw a radical that's going to be your face. You've got some eyeballs. So if you're thinking Frankenstein, these are his eyes. If you're thinking math student, these are your eyes, right? You start off the day and you're kind of a nice, happy math student with a cute little plus sign for a nose. But as the day goes on, you start getting a little sleepy and your eyes get a little tired. Frankenstein has kind of slits for eyes. We're going to do x minus x. You can do x2 minus x1 or x1 minus x2. It doesn't matter which. And then y has to be the same. So whatever x you start with, that's the y you start with. And whatever x you end with, that's the y you end with. But Miss Doherty likes things to be pretty, and Frankenstein has bolts in his head. So whichever way you think, you got to have those little square root or those 2 exponents up in the corner. We've also got exponents in Pythagorean theorem. So remember that we've got exponent of 2 in both distance formula and Pythagorean theorem. So let's go ahead to slide 13 and see if we can make some sense of this. So again, we've got Pythagorean theorem, a squared plus b squared equals c squared. You got to remember that. Take notes on that. Got to memorize it. Where the A and the B are the horizontal and the vertical pieces, right? And then the C is the diagonal. So the A and the B are what we square and add together. A squared plus B squared equals the C squared, right? So here we're going to take 8 squared and 13 squared and add them together and make it into x squared. And then you just solve that. You square them in the calculator, you add them, and then you take the square root, and there's usually going to be some kind of decimal. It's very infrequent, but occasionally you get a whole number. So if we come down here to the other examples that are done for you, so I'm not going to do a whole long time on this. What we've done is we've taken this point up here, and we've gone straight down and just counted 1, 2, 3, 4, 5, 6, 7, 8. That's my 8 squared. And then we've gone straight over. That's the horizontal distance, the other leg. 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, you got to make sure that you can make those straight lines. The floor is lava. You can't touch any of the white spot. You have to stay like on the tight wire of the grid. And then 9 squared. So 8 squared is 64 and 9 squared is 81. 64 and 81 is 145. Take the square root in your calculator. Remember, roots get smaller, so my square root is going to be 12. Find the distance over here between 2, 5 and 4, 1. Remember, this is to the right and up. So I've gone right 2 and up 5. This is 0.25. And then to the right 4 and down 1. So right 4 and down 1. This, my friends, is 0.4, negative 1. You can use the distance formula here. You've got the 2 endpoints, but it's just as easy to make that horizontal line. So the horizontal component is 2 squared because you count those jumps. And then you make the vertical line, that's 6. 1, 2, 3, 4, 5, 6. And then just square them, add them, and take the square root. Don't forget to take the square root. I can't tell you how many times somebody says the distance is 40. The distance is not 40. It's the square root of 40. Okay. You might want to pause here, do a couple of examples on your own. Over in Math Space, we're going to look at questions 1 through 14. I'm not sure which ones of those do distance this way. So I'm going to do the distance formula and then come back to the Math Space to give you some more examples. So if you come down here, you might want to pause for a second, take a breather, take a break, stretch. Let's go to slide 14. Slide 14 is going to be this distance formula. So again, this is Frankenstein space. Every time you do distance formula, you want to think about this. The distance is the square root. I've got eyeballs and a plus sign, x minus x, because I'm tired in geometry and I just want to go to sleep, and y minus y. And don't forget those squares. Remember, we're doing Pythagorean theorem, so we need those squares. Here, you're going to identify 2 points, x1 and y1, and x2 and y2. It does not matter which point is which. Lots of teachers tell you the first point has to be x1 and the second point has to be x2. It doesn't really matter. So you can see in this first example, we did x1, y1 first and x2, y2 second. And in the second example, we switched them around, x2, y2 and x1, y1. Sometimes what I do is I just try to avoid negatives. So we're going to do x1 or x2 minus y2, or back up, change that, x2. So distance equals x minus x squared plus y minus y squared. x2 minus x1 squared, and then y2 minus y1. The 0 and the 7 have to be the same ordered pair, and the 1 and the 6 have to be the same ordered pair. That's the important part. Then you just do your math. Make sure you put negatives in parentheses, because if you just put negative 1 squared into your calculator, you're going to get negative 1 instead of positive 1. Remember, a negative times a negative is a positive. Some middle school teachers do this graphic. I don't know if that helps. A negative times a negative is a positive, right? So a negative squared is going to end up being positive. And we end up with a square root of 2, or 1.41. Over here on the other side, we're going to do the exact same thing, but in the reverse order. So we've got x minus x squared plus y minus y squared. Here I'm starting with the 8. So if I start with the 8, then I need to start with the 5. And then I put in the 3, and then I put in the negative 8. Remember, we've got to subtract those, right? So negative 8 minus negative 3, negative 8 minus negative 3 is like negative 8 plus 3. So that's going to be a -5. -5 squared, negative times a negative is a positive. I end up with positive 25. Be careful with that. And then 5 minus -8, that's like 5 plus 8. 5 plus 8 is 13, 13 squared. And then you take the square root. Make sure you always take the square root. Okay? Take a breath. Make sure you've written down this formula a handful of times. Distance equals x minus x squared plus y minus y squared. The other way this can be, before we leave this slide, the other way this can be asked is instead of distance, we can be asked length. Length and distance are exactly the same thing. So make sure you put length and distance. These are synonyms. They are the same thing. Okay? So navigate with me over to Math Space. If you want to pause me, you can do that. And we're going to start with number 1. Select the diagram that shows segment AB. Well, remember, segments have 2 endpoints. So this is segment AC. This is ray CA. This is line AB. This, my friends, is segment AB. And then ray BA and line AC. So make sure you're finding the segment and the 2 correct ordered pairs. That should be a pretty easy question. I like it when they start off easy. Diagram has 2 congruent segments and they are marked. These congruent marks are how we mark line segments. So XY is congruent to XZ in this case. XY is congruent to XZ because of those congruent marks. So you want to make sure you look for those congruent marks. Question number 3 is going to be similar. The diagram shows 2 congruent segments marked. So we're looking for those tick marks. AB is congruent to DC. The order here doesn't matter. So we can do DC is congruent to either BA or AB. You can read that in either direction, endpoint to endpoint. So you're just going to write segment AB or BA. 4 makes it a little more complicated. There are a couple of different pairs of congruent segments. So the first pair, QP, is congruent to QR. So QR has 1 tick mark. It's congruent to QP. And I think this is going to give us 2 different things. So QR and QP. I don't know if capitalization matters or not, so we're going to find out. Input error. So anytime you get an input error, it's because you put the right thing, just not exactly the way they want it typed. Endpoints are usually capitalized, so it is going to be case specific. You're going to want to put capital letters in there. Nice work. Oh, and that is it. The vertical segment. So here you can zoom this in, I think. Maybe not. I thought you could zoom in. Anyway, so A to B is from 3 to 5. So that's going to be 1, 2 jumps. Probably the same thing here, but horizontally. So we're going from 8 to 3. So -8 to 3 is going to be 1, 2, 3, 4, 5 jumps. You can also do -8 minus -3. So -8 minus -3 is going to be 5. That is positive, right? Even though it's on the negative side, we have positive length. In geometry, we're usually talking about positive things. Question number 7, consider the graph of AB on the graph, okay? So AB on the graph, we want to know what is the vertical component from A to B. So if we drop down, right, I want to go A is at 3 and B is at 5. So that vertical component is going to be 2. And I know there's a way to zoom in. I'm just not sure how to do it. So if we draw our triangle, that's going to be 2 because I've gone from 5 to 3, right? And then B is at 1, 2, 3. This is -3, 2, 1, 2, 3, 4. So this is going to be 7. So my triangle is 2 tall and 7 wide. So my vertical component is going to be that up and down piece. Vertical is up and down, that's 2. Then the horizontal component is my 7. And then what is the length? So this is our Pythagorean theorem. If my triangle is 2 to 7, and you might need to sketch it out or go to Desmos and do it so your graph can be bigger. We're going to do 2 squared plus 7 squared is going to equal c squared. So a squared plus b squared equals c squared. 2 squared plus 7 squared equals c squared. That's going to be 4 plus 49 equals c squared, or 49 plus 4 is 53 equals c squared. Please, please, please don't be tempted to put in that 53. You've got to take the square root of both sides. So the square root of 53 equals c. And it's saying an exact value of c. So I think with the exact value, we're going to need to put in that radical and not estimate. Square root of 53. Anytime it says the exact value, you want to put this radical in, because if we take the square root, we're going to have to round some decimals. Input error, your answer needs an equal sign. So we've got to come back over here and do equals C. Okay, you should probably also be able to put in equals AB. Hopefully that answers any questions. I know these graphs are a little bit of a struggle. Which of the following formulas used to find the distance between 2 points? So remember, I need a radical. All of them have a radical. I need a little plus sign in here so I can eliminate my trash. Half of geometry is slashing the trash. I know this plus sign is my little nose and my face. And then I'm almost always going to try to stop from falling asleep in math class, so I'm not going to have wide open eyes. I'm going to have those closed eyes. I know it's terrible for a math teacher to say that, but it is what it is, right? So x minus x squared plus y minus y squared, all under a big radical sign. Question number 9, moving up, moving on. Find the missing values for the working distance between the 2 points. All right, so we're going to do x, y, and x, y. Instead of making them x1, y1 and x2, y2, I'm just going to color code them because I know the order doesn't matter. So if I've got the 5 and the 1 here, then I know that is this set, and I know I'm messing up my order here, and I'm going to do 3 and -1. Even though I'm subtracting, I also need that -1. So I'm going to input those numbers in here. Question number 10, find the distance. So now it's just time for you to shine. Remember, distance equals the square root of x minus x squared plus y minus y squared. Do this math on a piece of paper. Keep this in your digital or in your paper notebook, right? So I'm going to do x and y. I'm going to do -4 minus, and then 6 minus. And then I'm going to do my second set, minus -20 and minus 18. This turns into a super plus because a negative minus a negative is a plus. And then I can do -4 plus 20 is 16 squared, plus 16 minus 18 is going to be -12 squared. And that's definitely going to need some calculator help. Distance, enter your next step here. So my next step, ladies and gentlemen, is going to be probably this piece. So I want that square root. And then you're going to do -4 minus -20 squared plus 6 minus 18 squared. Hopefully that is what they want. So it's saying it's correct, but it's not quite right. So I wonder if they want me to simplify that into a plus. And this is where it can get a little bit maddening. So maybe it wants me to do x and y. You introduce the variables x and y, which are not needed here. Try again. -4 minus -20 squared plus 6 minus. I wonder if it is programmed to require it the other way. -20 minus -4 squared and 18 minus 6 squared. I don't know what it wants here. So let's just do the best we can on number 10. Maybe one of you can figure out what it actually wants in number 10. And I'll just count that correct if you get it correct and count it as a bonus. See if I can erase that. Find the distance between and leave your answer in exact radical form. So maybe it just wanted my final answer in the last one. X minus x, so 3 minus 5 squared. And then y minus y, so 3 minus -9 squared. Notice that I did 3 minus -9 and just wrote it 3 minus -9, right? So those are the exact same thing. And then 3 minus 5 is -2. Make sure you put it in parentheses to remind you that a negative times a negative is a positive. And then 3 plus 9 is 12 squared. So let's see if we can do this. 4 plus 144, or the square root of 148. And we put that in here. Square root 148. Nice. Let's go back to 10 and see if that is the way they wanted me to do that. So we had the square root of 20 minus -4 was 16 squared, plus 18 minus 6 is 12 squared. I'm reaching for my calculator. I'm going to pause the video so you don't have to wait for. So this is the square root of 400 once I got it into the calculator. And if I go and I take out all of this, I think I was making it harder than I needed it to be. The square root of 400 is 20. And number 10 is not nearly as hard as I was making it out to be. So it's just asking you the distance, the literal distance. So let's do our last 3 examples here. Find the exact distance. We want to determine which point is closer to the origin. So ladies and gentlemen, this is where I would open Desmos up. Open Desmos up, and you can graph M is at 1, -2. So that's M at 1, -2. And you can graph N at -1, -1, -1, -1, N, -1, -1. What they're asking you to do is find the distance between those two, and then ultimately they're going to want to know which one is closer. So we can look here and we can see that N is closer and M is further away, but we're going to have to find that exact distance. So find the exact distance from M to the origin, and that's going to be 2 squared plus 1 squared, and then the square root. So 2 squared plus 1 squared and the square root. And I did that by doing this triangle, right? So that's 2 and that's a 1. And then this one is going to be 1 and 1. So this distance is going to be 1 squared plus 1 squared and the square root. So the distance from M is going to be the square root of 5. And hopefully yours are different numbers than mine. And then the exact distance from n to the origin is going to be that 1 squared plus 1 squared. So the square root of 2. And which point is closer? Which point is closer? N was closer than M. And these are just time-sucking questions. This one was pretty easy, but sometimes they do get kind of hard. So definitely open up your Desmo. I can open up Desmos here and show us. You want to do Desmos Calculator Virginia. Desmos Calculator Virginia is going to give you all the tools that you get on the Virginia SOL. And that is not my graphing calculator, though. Desmos Graphing Calculator Virginia. There we go. So then we can put in our ordered pair, and I think it was 1, -2. We can label it, and -1, -1, and we can also label it, right? And then we can definitely look at that, and makes it a little bit easier to look at. Last 2 questions, ladies and gentlemen, last 2 questions. Oh, and actually these are segment addition questions. So we are all done. Guys, have a great day, and I will see you on Thursday.